Hello. So, if you remember last time I have brought up to certain point. Now, kindly look at my what do you call this thing, saying it is very convenient for us to use any flat material because most of the things are made and use the printouts as template. So, we have this template here. The intended material, you can always stick it on the intended material, then you can carry out operations, then any work spot like it could be or anything. Here it comes to mounting and fastening methods. Traditionally, in the case of molded parts, we have snap in place. Snap in place works well, but even there the first time simulating the snap fastener is a little tough. So, much otherwise probably use a screw or something, or even putting a tape is no problem. Holding two parts together, just about anything can goes and your prototype is ready. Now, let me start with a few samples. This of course taken from the available resources, and I acknowledge whoever has first made it and got this going. This one is a layout sheet prepared meant for probably laser trimming or laser cutting and assembling the whole thing together out of thing to make a beautiful system like this. Have you noticed this? This uses exactly all the parts that are described there, and in the corner have you noticed this? There is a special key like thing which is assembled here. This key probably sits here. You see here there are some places each will snap in place. Then you have seen these two things. These probably go and sit somewhere. So, you see here even production parts are made with flat sheets, and every time you need not go and depend upon a full fledged printed see the sequence. So, you have one pair part and then after that, see these are all the probably one I will call it one face and two opposing faces, something goes, and then I just pointed out to you about the key or some fastener which is put here, and the other side is there is a bottom which is stuck on these things. Why I am showing you this is probably this whole thing could have been made in a cardboard at home, because cutting a cardboard is easy. Now, you see here the moment you assemble everything, we already have a nice neat box, and then here this key has been shown here. Now, maybe you can relate that you push it inside and everything sits here, just opening, part of them are open, part of them are joined together. See how cute the whole thing looks. Now, let me take the case of something which invariably reality of fabrication is. Now, if you imagine one small, I will take this. See here, it could be any, this is just made as a student exercise. The idea being cuboid structure, and there are the basic 6 faces. Right now ignore, of course there is a 7th face, ignore that. For you to understand typically the size, how you will hold it in the hand and so on, you have seen this. That is my hand, and the whole thing is assembled by making things out of a simple cardboard. In this case it is a hobby cardboard, and two important details you will notice. I am sure you notice this. In the front there is a small tab, and at the back one more tab is there. Function is tab is that it will hold the structure together, and it can also be used as for the fastening technique, putting one on top of the other. This being a flat object, it is exactly how something made out of polystyrene or something made out of acrylic or something made out of PVC, something made out of polycarbonate can probably made as well it is. Yes. Now you see both of the parts are put together. I have noticed some very interesting thing about it. First of all, just for simplicity's sake, thickness has been ignored. But in the case of sheet metal, we will need to consider the thickness. And you see a gentle inward curve is given that will ensure that things fit. Now you see this is a development drawing, I mean not development drawing, a developed sheet based on a development drawing that has been probably pasted on a A4 size sheet, and they have just trimmed it according to that. The important thing, one more time you will notice, is that see this taper, notching, and a small detail which I thought I will help you. You see here this line AP has to run almost in the same line as this. Why do you need it? Fabrication will be easy. This may not have come at the first shot properly, because if this were to be a little different, then which is the first cut that needs to be given in the workshop and all that, no, somebody has to work on that. So a little bit of thought has gone into that, and transferring such a thing directly into fabrication in large numbers is very, very easy. I just wanted to, as part of this, you have seen this, that is all that is needed, nothing exotic, nothing big, nothing very different. Now, this is a slightly modified version of the other thing. If you are to use any other material other than the cardboard and which cannot be easily bent, much easier way would be to probably make it into separate pieces. So here it is probably made out of an acrylic material, or in our case generally what we do, top cover, this portion of it will generally be made of acrylic so that somebody can see inside, and this whole thing will be made probably out of acrylic but opaque, that it looks a little like a project, but then you can place this on top of it. Now we come to the interesting thing, now saying what about the front panel which you are talking about. You see here all these pieces are small pieces. Now first time you will discover as part of your prototyping is that thicknesses are involved. Can you see here? There is a thickness, and now we need to take a decision saying the height of this, does it go inside this and this portion covers it fully, or alternatively this is one portion and you have it as side two end caps. Depending on your design and various things you would like to have, you need to make a decision to subtract the necessary thicknesses. Now we come into this corner, you have seen this here, this is cut normal, this is also cut normal to the surface. Does it match? Of course it does not do, but you see here, the way this is shown, there is a nice beautiful if I assume that this is a 45-degree angle, we have 90 plus 45, 135 degree here, it does not match easily. So, at this point no, a good craftsman or you just need to match things and put up with it as things are. Now, we come with a very clever alternative. Why need to match it at all? Why can't you let the top portion overhang a little? Let it overhang. Similarly, let this overhang a little, let this be recessed inside, and the moment you make this overhang by say little 2 millimeters, you can have the side panels also jut out by about 2 millimeters. So, you have a bezel like structure, 3 times a bezel like structure, and you can probably hide all the imperfections. And part of the advantage is saying from the inside probably these two can be joined together using simple super glue or hot melt. See this, of course it looks miraculous, they have all been attached together, and now what was a thicknessless thing, suddenly there is a thickness. You need to just put these things together, and the other side of the view, see this, looks all honky dory, there is no issue problem at all, except the little honky doryness will probably needs to be cured. You see this corner, this corner seems to be a problem. In the original development, we have just assumed these things fit nicely, and then in this corner you will see a very, very interesting problem. This being a sheet metal exercise, you will see that there is always a radius here. Can you see? You have a radius. Now, how do you let the radius match with each other? We have chosen to ignore it, but actually there will be a gap here, and when it bends here, you need to give a corner relief for the whole thing. So, we come to actual manufacturing practice, and this is what I was telling you here. You see this internal, and you see this internal, this appears sharp, but that has a radius. Something has to be done to address all those things. Eventually, when you put everything together, things should look neat. See here, neat, neat means neat. Now, let me get on with a little slightly different, a universal what you call enclosure. Often you find this in the catalogs. In the catalog, you will find this saying these are IP, that is index of protection 54, 55 class of standard electronic boxes. You will discover some very peculiar situation by which your particular requirement does not fit into an available standard unit, because you have not started with that. You have not started with the standard enclosure and arrange things so that they can suit you. And unlike the BeagleBone and unlike the Raspberry Pi and unlike the various other things what I have shown you Arduino, this is not a standard for which this IP enclosure has been made. IP enclosures have been made in a fairly interchangeable sort of universal big system. So, if you are smart and you know some idea that you are replacing another equivalent existing unit, you can use one of those standard modules and try to fit your electronics, especially non-PWB hardware. I have mentioned you right in the beginning itself. We have connectors, we have control elements, we have often displays, we have so many of these things which go into that. So, if you see inside one of these enclosures, is actually not a molded enclosure. This has been just created in a solid modeling what you call exercise. What has been done is taken 4 sides of a layout with which we are familiar with, saying, imagine I take this mobile. Now, I want to put something on this side, probably a battery, and probably I need to put something else and so on. I need to make it into a neat enclosure which fits close, extremely close, and that enclosure may need a little embellishment, saying I will now use this as a test platform or something, and then that particular test platform requires a larger battery. So, I look for a low profile, probably 10,000 milliampere lithium polymer battery bank which goes behind it. Now, if I have to put the whole thing in an enclosure by putting everything, I have a test platform which can nicely have something which you can go on, so that every time you need not plug it. Now, why do we need it? I may use this mobile as a data acquisition unit. I can put it maybe in one corner of a room, connected to a Wi-Fi camera or something, and mind you, I am not using any standard thing. I am building it, and then I am building an app on this. I am building everything, and this whole thing will go into the type of box which I have just now shown. So, we have a look at it. This looks a little like this. Actually, it is nothing, just for what you call our my satisfaction, we have rounded it. 4 side faces of appropriate height have been taken, and this corner pieces have been attached to that, and make things a little more. This has been filleted on the outside, but you see in a thing, no, otherwise there may be a fillet here. They have been filleted, everything has been joined together. It looks as good as a manufactured item. Now, standard operations like drilling has been done, and at the back, I am sorry, and on the top you have this. Now, you have a box, or you have an enclosure which is ready for me as I want. Notice something here, this is probably the back, and then you notice something here, something which is very, very interesting. Counter bore, and then on the other side there was a something where it matters with a small adjustment. So, you can build in detail, saying how you would like to deploy it somewhere. Do you need to have a clamp, attach it somewhere? All these details can easily be worked out. Now, I will come back to a small thing I am sure which several of you have seen. This is actually one of the small items which comes with our earphones. A thing like this eventually will be made in plastic, but if you are to make it in sheet metal, you will end up with a very, very unpleasant thickness all around it. Because of the small size, this thickness looks very, very daunting. Now, we come to the equivalent sheet metal of it. Imagine that particular thing needs to be strong. Like if you throw it, it should not break. It should not be made out of a brittle plastic which is likely to shatter in the corners. So, we end up with the sheet metal version. If you look at it, no, you have seen the sheet metal version. This is what I was trying to tell you. This corner, we end up with very peculiar detailing. There is no way of it. Only other way is probably you go in a little that side and then bend it up like this. So, overall the dimensions can be maintained. Interesting, isn't it? This is where making a simple prototype helps. Even our people who work on the sheet metal often make that sample. Just they take any available material. In the case of, in my this thing as an engineer, probably for your cardboard is better, but in their case what they do is usually there will be some surplus or scrap material. They make a print, stick it on the that surplus actual material which is likely to behave a little like the original material, then carry out all the operations and then do the correction in the main drawing. For example, one of the things I tell you, I take it that approximately there is a box of some given dimensions. I take it from one side to the other, this may be around 30 millimeters, other side may be 50 millimeters. So, 30 by 50, while it looks very fine here, you need to compensate on taking this thing inside. We take a small thing inside here, and once you take it and make a bend here, this thing becomes a little, it likely to jet out. All these dimensions, everything can easily be worked out in any CAD program. Typically, most students which I come across are familiar with either Solid Edge or SolidWorks, and most of the either by Dassault or by Siemens or so many other or any of the Autodesk products also have a sheet metal variant, a sheet metal add-on. Those sheet metal add-ons take care of all these details, but the main problem is data regarding the compensation, what is called the bending allowance, and behavior of the material, saying what is the minimum internal radius and the type of fabrication machines you use. Everything is a variable which has to be taken from the physical shop. This is the problem, not problem actually, this is a real issue with all the simulation work. There is a physical phenomena. Based on the physical phenomena you simulate, and then you find that one particular ratio probably needs to be altered a little, and then hence you can improve the material and then either search for the material or make a compensation. The same way in the case of our these things, one needs to still make a sample piece of the final thing, especially sheet metal, and note down all the details. In absence of this, for most standard materials, data is available. It may be off by maybe 0.1 or 0.9 millimeters, but I am sorry, 0.09 millimeters. In general, it is very accurate and it does not really matter. For these things, once again allow me to stress that the starting point is probably a good CAD drawing and a concept in the mind. Now, let me see what the next one is going to show. I do not know which part of it is material, what you call metallic, which part of it is this thing. Now, you see here we have beautiful, I think I have covered this. I will now go back and pick on something slightly better. This is the laser trimmed or laser cut materials which are available on sale. Something have you noticed, for example, your particular project may not need these two things, may not have audio at all, you may not be interested in audio, and you may have an SD card, but you may not have a what you call OTG on the go cable, and in this case nicely a USB, I am sorry, non USB, a 5 volt power supply is shown there, but you may be using a USB, and then the serial port is only at the time of programming, probably you need it, you need to have a tab which can cover it. So, now you will notice that once you get all these items, this is a kit. Now, what about this? So, This is probably made by one of our students. You have seen this here. While this is actually made in a laser cut provision, I am sure the whole thing could have been easily made by you in any other material. This of course is a professionally made item. So, you have various things which are sitting here. So, you can see these things can be built easily. Yeah. Yeah. If you remember, the earlier slide showed you about the corner that needs to be taken care of. First time when you go to the fabrication shop, you will notice that these details, while they are critical, are probably killing the product. As you know, you wanted a product which does not have everything, it looks neat. All the renderings I have made look too neat to look good, but this is the reality of that. So, how do you get over this? One of the reality is a radius. Another reality is gaps that do not close. Fortunately, this is not your problem. This is the problem at the fabrication level. For the first time, remember, you are likely to make everything out of assembled sheets, and then you show this, their process planning people will try to work out what best to make things. You see here, there is a very ugly sharp edge. When somebody tried to work on the sharp edge, it did not come out well, it only made worse. It looks crazy. This is a drawing made by one of the very common 3D programs. It is not by definition what I call full fledged prototype making what I call an app or software. It just shows the dimensions I want, saying I need this is probably this 80 by 120, this thing would have been maybe 25 or 30 millimeters. Moment I have it, now why this has been made is, see this corner, so this corner. So, what shows 80 is correct because it is visible, but this side plate need not be 120, it will be 120 minus 2 of the thicknesses. Looks insignificant or trivial, but this is the one that makes or breaks your product. Once you take the initiative and making these things properly, you will have nice neatly made corners. And you see here something else next. You can even, in case you are using acrylic sheets and all that, you can probably use grey plastic, and I do not know why I have chosen green, just to show that I can choose green, and the top cover is a LED red filter. You can make the whole thing in probably one whatever it is, and then add a small filter, all the full thing can be made this, and remaining thing can be masked. So, it look like a real life product. So, you have the advantage of happily using the smallest things available and trying to come up with things which perform identical to the main material. And if you are lucky enough to have at least 3 mm or 2.5 and 3 mm sheets, you can directly work in plastic sheets. Alternately, for the first 2 rounds, you can work with cardboard, as I said, foam core. So many of these things are available. So, I will stop here because it is it's still quite a lot of things that have been covered in a particular thing. I will just show you, though which is not directly related at the point here. This is exactly what I was trying to show you. Now you will be asking, sir, you have started with what was obviously something to do with make things simply. Why are these required like that? Just I wanted to show you that in real life these things are involved. I will not go into detail for this at this stage, because by definition I wanted to stick to something which you can make at home, which we now come into another important aspect of things. Even thick cardboard, anything more than 0.5 mm involves a radius and involves a bending. Now how do you take care of this bend? And as I told you, you have a inside radius, usually you have an inside radius, okay, then you have an outside radius. And how do you make these things take a bend neatly? Just try it, take a piece of cardboard, try to bend it a little here and there and see how well it goes. So thank you, I will stop here. Meanwhile, I want you to think about a universal remote which you use in your workplace. In the case you are a student and you have your own room, what are the various things your remote needs to have? It should not be very complicated like the ones that I have shown you, that so many knobs, so many things which are not that really relevant to us, and if anything they are only distracting. And if you have a app, yes, you can work with an app and all that, but these days remember a lot of apps refer to having a Wi-Fi somewhere, or they insist on Bluetooth connectivity. A lot of devices may not have Bluetooth connectivity. And what do you do with the old audio set, or in the case you have a sound bar, and in the case you have a television, and the television has a set-top box. And here we get into that very peculiar thing. If you have a set-top box and a TV, probably you will be playing, you will be only controlling the set-top box and definitely not having further control on the main display, because if you play with any of those elements which are on the remote, you will lose the picture, because it will go off into separate input mode, separate output mode. And some of the remotes which come with us have teletext and Oracle, which is, I do not know if it really works, or it's something they tried and it never took off. The remotes still are made in probably large numbers, and there is nothing we can do about it. So think about it. I want you to think about a simple remote, simple thing which you would like to probably have around, which you can make in your time, which will control devices around your environment. So audio is one of them, external audio. In case you are one of the people who try to wear a hearing aid, I am not a hearing aid, I am sorry, earphones, can we control that, and then something and all that. So keep this in mind. Next lecture I will try to present what I tried to make, rather I asked my colleagues to help, and then what they are trying to make. So thank you, I will stop here.